The first thing in SP2 is resultant forces. So, if you have an object, and let's say it's a car on a road, we'll do it horizontally. The car might have a forward force from the engine of 200 newtons. It may then have some drag or air resistance of 100 newtons backwards. If you want to find the resultant, you have to subtract forces in the same plane. So horizontally, the resultant would be the biggest, 200, subtract the smaller, gives you a resultant force of 100 newtons to the right. Okay? Remember, your forces are vectors, so if you are finding a resultant, it's probably going to require a direction. Yeah? So it could be left, right, or it could be up and down. So if you draw another one, do it here. You have an object. Obviously, it has a weight down, which could be 1,000 newtons. It may also, therefore, have an up thrust or, again, some air resistance of 500 newtons. The resultant force, call it Fr, is 1,000. The bigger, subtract the smaller in the same direction, gives you 500 newtons. Which way? Down. Okay? That's as far as resultant forces go in terms of paper 1. Paper 2, you actually have to find components and do it slightly differently, but for paper 1, resultants are either up and down or left and right. Now, if you have a resultant force, or if there is a resultant force on an object, then that object must be accelerated. So resultant force equals acceleration. Okay? If there is a resultant force, it means there is a force on an object in one direction that is bigger than the force in the other direction. So if there is a resultant force, the object is accelerating. If there is zero resultant force, then forces are balanced, then there are two options for the object. Either the object is stationary, or it moves at constant speed / velocity. Okay? So they are your two options. If you have a resultant force, the object must be accelerating, and if there is zero resultant force, i.e. the forces are balanced, then the object is either stationary or it is travelling at a constant velocity. It depends on the situation. Okay? So if it's an object on the table, the two forces acting on these pens are the weight of the pens and then the normal contact force from the table. Now, since these two pens are not moving, they're stationary, those two forces must be balanced. There is no resultant force. Okay? But if you throw the pens and they accelerate to the ground, the weight which is acting down must be greater than any air resistance that was trying to pull it back. So there was a resultant force when it was falling, there was no resultant force when it was stationary. Okay? But if you have a car and there is a force from the engine of 1,000 newtons and there is also an air resistance of 1,000 newtons, what would you say about the motion of that car? Is there a resultant force acting on the car? Zero. Because 1,000 take away 1,000 is zero. So, I only have two options. Either this car is stationary or it's moving at constant speed. Which one would be more likely?
Stationary.
No.
It's
It's constant speed because there is a force from the engine. The engine is running, it's providing a force, it's just the air resistance has managed to balance it. So it is travelling, but it's constant speed. Okay? So think about the situation and think about, would this car be moving, or is it likely that it's just sitting? But if the engine's running,
unrealistic to have a force of air resistance.
it can happen now. If you're going fast enough, eventually you can reach terminal velocity. Yeah, alright, but as an example. Okay? Now, this is very important. These two statements about resultant force take us to Newton's three laws. So, Newton's first law. Okay? If no, usually external, but we're going to go with resultant because it makes more sense. No resultant forces act on an object, remains at rest, all constant velocity. That's Newton's first. Alright, which we said here. His second law, which is about the other statement, so Newton 2. If there is a resultant force on an object, then the object accelerates in the same direction as the resultant. Okay? The equation that we had in our equation list, which applies to this law, is F, the resultant force, is equal to the mass of the object multiplied by the acceleration, right? So this resultant force, which could be that car there with 200 forwards, 100 backwards, if that was the resultant 100 newtons to the right, then the car will accelerate to the right, and it will depend on the mass of the car, yeah? So the force is equal to the mass times the acceleration, okay? Newton 2, and Newton's third law. Okay, Newton 3. Every action has an equal and opposite reaction. Okay? Equal meaning it will be the same size, opposite meaning it will be in the opposite direction. Okay? Now, if the action, let's say there is an object on a table and it has a force of weight down. If the action is the weight of this object, then the reaction must be, bear in mind that this object is on the earth, it must be the force from the object pulling the earth. Alright? Very, very common mistake is people say, right, if there's weight here and normal contact force on this object on the table, like the pen's on the table, then action is weight, reaction is normal contact. That's not correct. Because it has to be between the same two objects. Now, weight of an object is caused by the earth, right? The only reason you're sitting in your chair is because the earth is pulling you down. If the action is your weight, which means earth pulls object, the reaction has to be object pulls earth. It has to be the same two objects. Okay? But if you said that the action is force on table, the reaction could be
table on
exactly table on object. That's the only time that this normal contact force can be reaction, if you say that the action is the force of the object on the table. Okay? But if the weight of the object is the action, therefore the reaction must be the object pulling the earth. Yeah? Okay? And that's Newton's third. So any force, absolutely any force, must have an equal and opposite reaction. Just as long as it is the same two objects, same size, opposite direction. Okay? Mass and weight. I'll leave those laws on for you now. Difference between mass and weight. Okay? Mass, we know, is measured in kilograms. This tells you how much matter is an object actually made of, right? So all the atoms in the object itself gives it its mass, but weight is measured in newtons, which is a force due to gravity. Okay? So weight is the force acting on the object due to the gravitational field strength. So force on object due to gravity. Okay? So, if you take an object and you have the object on the earth, you take it to the moon, the object's mass will not change. Whatever the object is made of is still going to be made of the same thing on the moon, but the weight of the object, because the weight is due to the gravity, and we know that gravity on the moon is less, the weight of this pen will be less on the moon. Yeah? Gravity on Earth, remember G is 10, so if you are in an exam and they don't say G is 10, you have to remember yourself, units are Newton per kilogram or meters per second squared, because it's also an acceleration, which is why things fall. Okay?
So I think this division and ask some similar example in this paper. Why is acceleration measured in meter per second squared?
meters per second squared means meters per second per second. That means how is my speed changing every second? Yeah? So it's just meters per second per second. Okay? And that's the difference between mass and weight. Equation, remember, W equals M times G. Yes? Moving on, we've done second law, we'll save that, we've done the third law, momentum. Okay. Can I get rid of Newton's laws?
Yeah.
Okay. Momentum. Equation, P equals mass times velocity. Okay? The momentum of an object is essentially just a quantity that determines what is the mass of this object and how is it moving. Yeah? So something to do with the object's speed and its mass. If we say the mass of this is 10 kilograms, it's travelling this way with a speed of 2 meters per second, then I can tell you that the momentum of this object is 20 kilograms meters per second. Okay? If I just want to calculate momentum, it's very simple.
What's 21?
kgm/s. Yeah? That unit times that unit. Okay? However, if there is an object that is waiting here, mass 5 kilograms, but it's not moving, it's stationary, then this object is going to collide, right? This truck that is travelling this way with 2 is going to bump into this. Call this truck A, this truck B. Okay? You may be given a question that says, before the collision, truck A is travelling at 2 and it hits B, which is stationary. After the collision, there are 2 options. 1,
They join together.
both trucks travel together with a speed of, let's say, 1.5 meters per second. In fact, we'd actually be asked to find that. So let's say, find the velocity of the trucks after the collision when they move together. Now, I know the mass together is 10 plus 5, so total mass is 50 kilograms. Okay? The equation or the process I have to go through if I'm doing a momentum question is momentum before, so this is before the collision, is equal to,
Momentum after.
and why is that?
No.
Begins with C. Momentum is always conserved. So, momentum before I have to do separately because they're moving separately. So I do momentum of A equals 10 times 2, which is 20, plus 5 times 0, which is 0, equals, has to be the same as this. 15 times velocity that we don't know, let's call it V. Okay? So 15 multiplied by V. Now that 0 means nothing, so 20 equals 15V. If I want to find V, like I do in maths, divide by 15. So V equals 20 over 15. Is it 1.5? No, it's not.
4.3.
You got a calculator?
I will see it.
It's not
I
1.5.
It is.
4/3.
Yeah.
No, it's not.
It's 1.3.
How many?
1.3 recurring.
1.3 meters per second. Okay, use a calculator in the exam, yeah? Okay. The only other alternative could have been they move after this one. They still move separately, but what's happened is this truck has hit this truck. So they're still moving separately, but some of the momentum of this truck has been transferred to this truck. So this one still has mass 10 kg, this one still has mass 5. This one now has a speed, still moving that way, but it's lost a lot of its momentum, so it's moving at 0.5. Calculate the velocity of truck B after the collision. Okay? So, go again. Total momentum before, 20 plus 0 equals. This one's now moving at 0.5. 10 times 0.5 is just half of 10. So 5 plus this one, which I don't know, 5 times B. Okay, it's the same thing, but I have some extra steps. Get rid of the 0 because it does nothing. Subtract the 5, which is 50, 5v. Divide by 5 is
3.
3. Well done. 3m/s. Stop. Thank you for getting some recording.